Welcome to the new chapter. You survived chapter 2, maybe. Anyway, so chapter 2 was heavy on the applications. We talked about graphs, increasing and decreasing, concavity, points of inflection. Then we talked about applications, finding maxima and minima, constrained optimization, inventory management, and then most recently, applications for business and economics. Chapter 3 is just taking derivatives. This week and next week is Chapter 3, only just taking derivatives, okay? And we'll talk about some rules. So specifically in this section, in this week, we're going to talk about the product and quotient rule. Specifically in this video, we're talking about the product rule, okay? Because if we're taking the derivative of two things that are multiplying by each other, so the derivative of maybe some function f of x times some function g of x, we can't just take the derivatives individually. If we add things, yeah, you can take the derivatives individually, add them together. Subtract, yeah, just do it individually. Multiplying, it doesn't work. The reason why, I could show you with that limit definition of the derivative. The limit as h goes to 0 of f of x plus h, all that fun stuff. I could show, but I'm not going to. If you're curious though, talk to me, I'll do it. All right, it's going to be the derivative of the first function times the original second function, plus the first original function times the derivative of the second function. So this looks kind of weird, but this is what's known as the product rule. All right, sometimes we'll have some shortcut for writing this. All right, if I have two functions and I want to take the derivative of them, it's going to be f prime g plus fg prime. That's just a kind of a quicker way of writing it. And so, yeah, it's really kind of neat where this comes from. But again, the proof involves that limit that we're not really going to do today. This is an applications course in general. So we're just going to have to use this. F prime g plus fg prime. Each pair, and it doesn't matter what order they're in, is just one original and one derivative, plus the other derivative and the other original. Okay? I think I got rid of my prime there. So let's get using it too. Example 1. Show that the derivative with respect to x of x squared x cubed equals 5x to the fourth. So hopefully at this point, you also know how to take this derivative without the product rule, right? You say, well, x cubed times x squared, that's x to the fifth. You just add those exponents. The power rule on x to the fifth is 5x to the fourth. So this is just practice using the product rule, okay? Even though we know how to do this the other way. So let's label these things. This will be our f, and this will be our g. So our property says that what we should have, right, this derivative, the derivative with respect to x of these two functions, according to our product rule, says we're going to have f prime g plus f g prime. Okay? My phone is buzzing, so I'm throwing it on the ground. Sorry, cat. She's in my lap. Anyway, so we just plug things in. Well, what is the derivative of f? The derivative of f is 2x times g, which is x cubed, plus f. F we said was x squared, times the derivative of g, which is 3x squared. Right? Again, we do have this correspondence, right? F prime is 2x. G, x cubed. F squared, g prime over there. We're just plugging it in. Now, if we simplify, we should get 5x to the fourth. 2x times x cubed. Remember, it's like 2x to the first power there. Add the exponents. 2x to the fourth. Plus 3, add the exponents. X to the fourth. 2x to the fourths plus 3x to the fourths. We now have 5 of them. 5x to the fourths, which is just what we wanted. Happy face. Kind of an evil-looking happy face, but a happy face nonetheless. It's supposed to be happy with joy, not malice or greed or whatever that happy face looks like. I do that a lot. I did that in my other class a couple weeks ago too. That's the product rule. Let's use it some more. Example 2. Find dy dx, or y prime, for the following. Part A. y is going to equal 2x cubed minus, not a minus sign, Jason, nice try, minus 5x times 3x plus 1. So one way, before this chapter, if you wanted to do this problem, you could just FOIL this out, simplify, collect like terms. We're going to use a product rule just for practice. So this first thing will be our f. This second whole thing will be our g. Let's see what we have. Y prime going to be the derivative of the first thing times the second, plus the first times the derivative of the second. I highly recommend writing this down every single time you use it. 2 reasons. 1, I'm not giving you the formula, so it's a good way to memorize it. 2, really does make it easier to plug in each time. So what is the derivative of this first thing? It's going to be 6x squared minus 5. And we're multiplying this by something, so we are going to need parentheses. Our original g is up here, 3x plus 1. Now we add to that the first function, unchanged, 2x cubed minus 5x, times the derivative of the second function, which is only 3. 3x plus 1, that's a line. The slope of the line, 3, that m value. All right, and so this is where we're at. You could simplify it if you'd like, but for most of these, I'm not going to ask you to simplify. Unless I specifically say simplify, I just want you to get some practice using the product rule. All right. Feel free to ask me, like going into a quiz. If you're studying for the quiz and getting ready for the quiz and go, is he going to want us to simplify here? Just shoot me an email, message me on Slack, and I'll try to clarify. Okay. I'll try to be very clear about that in the quiz. B is going to be g of x times g of x. So right, this is g of x squared. We already know how to take the derivative of this with the general power rule. But I'm going to show that it's the same with the product rule. Okay. So product rule says we take the derivative of the first thing, which is going to be g prime of x. We multiply it by the second thing, plus the first thing, which is g of x, times the derivative of the second thing, which is g prime of x. And these are the same things, right? They both have a g times g prime. We'll just add them together. We have 2 of them now. So 2 g of x times g prime of x, which is exactly what we expected with the general power rule, right? And general power rule says, okay, bring that 2 in front, subtract the power, and multiply by the derivative of the inside. So it did expect 2g of x, g prime of x. Oh, I missed my prime. Something to be said about missing your prime. Anyway, here we go. One last example problem with the power rule. Part C. Y equals, let's get some real nasty, x squared minus 1 to the 4th times x squared plus 1 to the 5th. This one, you really don't want to expand out and simplify. This would take forever. You'd have to use the binomial theorem, and it'd be a little messy. So, binomial theorem is pretty cool, by the way. If anyone ever wants to use it, I'm willing to tell you about it. So, let's use the product rule. This will be our f. This will be our g. And the derivative is going to be the derivative of the first function, f prime, times the second function, plus the original first times the derivative of the second. Just keep writing the product rule every single time. And then we have to look at, oh, hold on, let me be a little careful here. F is this whole function. G is this whole function, including the exponent. The exponent. I was trying to make a bad F joke. It did not work. We'll scrub that from the video. Anyway, so we have to use a general power rule on these derivatives. So when you take the derivative of f, that 4 comes down in front. The inside remains unchanged. 4 gets reduced by 1. That's the power rule part. General power rule because the inside is a function of x. So we have to multiply by the derivative of the inside function here. So this right here is just f prime. And then we have to multiply this by g. That's just the derivative of the first function. So we multiply it by the original g, x squared plus 1 to the fifth. And now we do that again, plus f, which again is x squared minus 1 to the fourth, times g prime. The derivative of g also requires a general power rule, and I'm not going to have room here. I'm going to write it down here. I'm going to need more room than that. I'm going to write it down here. For g, bring down that 5. Inside stays the same. Power reduces by 1. Multiply by the derivative of the inside, which is 2x. So we have f prime times g plus f times g prime. And there's the power rule in all of its beauty. And here, again, you can simplify a little bit. It's kind of a wacky little simplification. I'll do it here just to show it to you, but I'm pretty sure I'm just not going to ask you to simplify. Just a lot of time and mess. So for this first term, we can multiply the 2x and the 4 together, no problem. That becomes 8x. And we're still left with an x squared minus 1 cubed times an x squared plus 1 to the fifth. For the second one, we can multiply the 2x and the 5. We get 10x. Again, x squared minus 1 to the fourth times x squared plus 1 to the fourth. And then a lot of times it's not terrible to just end here, but you can actually go a little bit farther. Sorry, I was polishing my 5 a little bit. Let's see if I can do this. I'm trying to do this earlier. Actually, no, I don't. Not going to go for it. So we can just factor out a greatest common factor. But let's just end here for now. This is good. That's the product rule. So it's messy, but with the exception of the formula, it's just taking derivatives like you did before. So review your general power rule. Be very careful with constants and exponents. All right. And you should be good to go for these chunks of problems. Good luck.